All right, last thing we're going to talk about when it comes to descriptive statistics before we move on to other things is the variance or the standard deviation. So we talked about this a little bit in class, if you were in class and you remember, but just to sort of have it on our Google Classroom, have a video for it for those of you that might not have been there. The variance really just measures the average of the squared deviation. So a deviation is just how far away is each value, each x point from the mean, that's the x bar, and it just squares it. So all we do is we add them up, square them, the deviation, so x minus x bar for each one. We square those, and we divide by the number of data points, and that gives us the variance. If we want the standard deviation, we take the square root. And I've noted down here, we talked about this a little bit already, but there's a difference between the sample and the population. So if you think that you have all of the data, all right, then the variance is this. It's the sigma squared, and the standard deviation is sigma. And it's just typically what we're going to do, we're going to assume that we have the population and not a sample, but there are two separate ones. So this is the standard deviation of a population. Where are you going to use this? Where mu is actually standing in for the mean of a population. So we're going to assume that we have all the data points. That's not always the case, right? A sample is just if you were polling for an election, then you would take 1,000 people out of a province and say that, based on this, we can assume that this is the amount of people that are voting for each party and those kind of things. You sometimes will see a sample done that way. But what we're looking at typically is going to be population. So when we look at this, the first thing we have to look at is I need the mean in this formula. So here's an example, and I'm just going to show you sort of how to set this up, and then we'll show you on the calculator how to actually do it, because it's probably easier to do on the calculator. But we're going to take this example of Sally and Joanne, who are netballers. It's an Australian game. It's like basketball. It's somewhat interesting, though, because it doesn't have a backboard, and you should look it up. You're already on YouTube, so go check it out. But you can see from their data that one of them is relatively consistent just from looking at the numbers. The lowest number is 17, the highest number is 32. So pretty consistent. And then Joanne, the other girl that's playing, is a better scorer in some games. She scored higher numbers in a few games, 44, 41, and 38, but then she's also scored only 14 and 9. So we expect that Sally is going to have a better standard deviation, because if there's less deviation in the data, it's more grouped together. So when we look at the mean, first of all, I'm just going to show you how to set this up just in terms of what it would look like, and then we'll do it on the calculator. But the mean would be this: 23 plus 17, you just add them up, 17 plus 25, and so on. And then you're going to get a number. So we're going to take our calculator, and this is my TI Inspire, but you don't need a TI Inspire to do this particular thing, but when we actually use them, you do. So we're going to take 31, 17, 23, 25, 25, 19, 28, and 32, and then we're going to divide that by 8. So we're going to hit divided by 8, and then I'm going to ask it to tell me what that is as an average. It's 25. So we go back to our mean, and we say, okay, 25 is her average. All right. And then to get the standard deviation, we take each number. So we say it's the square root, first of all, of each number. So 23 minus the mean, 25 squared, plus 17 minus 25 squared, plus 31 minus 25 squared, plus 25 minus 25 squared, plus 25 minus 25 I'm going to run out of space here, squared. So we'll just jump down here. I know this isn't necessarily proper notation, but we ran out of room. 19 minus 25 squared. Oop. What is it doing? Squared plus 28 minus 25 squared plus 32 minus 25 squared. So all of that underneath the square root, and then that whole thing, I'm going to go just underneath there we go, divided by 8. And that will give us our standard deviation. Problem is, it's very tedious to type in. And so what we can do is we can ask the calculator to do it for us. So I just wanted to set that up so you can kind of see how the formula works, but I'm not going to type all this out and do it. What I'm going to do instead is I'm going to take my calculator and I'm just going to go into Documents and open a document. And I'm going to add a list. And I'm going to, in that list, I'm going to call it data. And then I'm going to go back to my numbers and just type them in. So 23, 17, 31, 25, 25, 19, 28, and 32. And then what I'm going to do is I'm going to ask the computer, the calculator, I'm going to go into Menu, I'm going to go to Statistics, Stat Calculations, and One Variable Statistics. And then it's going to say One Variable Stats, yep, it's one list. The list is, the X list is data, and the frequency list is just one. Each data point happens once. And then it's going to put my results in column B, and I'm going to hit OK, and there's my standard deviation. And if you scroll up a little bit, there's my mean. So my mean is 25, and my standard deviation is 4.97494. And if you work this out, we go back here, if you work that out, it will give you that same number. So that's how you use the standard deviation. The only other type of standard deviation is, what do you do if you have a cumulative frequency kind of thing? You have a frequency table to go with it. And what you do is you simply just add up the frequencies, that's your number of data points, and you do x minus x bar, so you take each of the numbers, 50 to 54, 55 to 59, you take the split, so you take the number in between, so 52, what's that one and a half, 57, and so on, and you subtract the mean, square it, and divide. So I'm just going to show you how to do that with this example. So this is an estimate because we don't know exactly what two numbers are in this. It could be two 50s, it could be two 51s, it could be a 54 and a 51. We don't know. So it's an estimate, all right? And we're going to go down here. And the first thing we're going to do is find the mean. So we're going to take 52 because that's halfway and multiply it by the frequency of that grouping. Then 55 to 59, we're going to go 57 times 1 because there's only one. 62 times 7, 67 times 18, 72 times 11, and 77 multiplied by 1. And we're going to divide it by the total number. And if you add those up, you get 40. And that gives you a mean, 66.75. And then what we do is we go into our standard deviation formula, which is up here. We take the frequency multiplied by the number subtracting the mean squared. So the first frequency is 2. So we take 52 minus the mean squared times 2. The second frequency is 1. So we take 57 minus our mean squared times 1. Then 7, 18, 11, and 1 again. And that will give us our standard deviation. All right. So that's how you use the formula. Now, if you want to do it on the calculator, all you have to do is put your data in here. So I'm going to just close this out and get a new one. So I'm going to go File, New Document. I'm not going to save the old one. And I'm going to put a list and spreadsheet in, and I'm going to put my data in here. But then I'm just going to put my frequency in here. So I'm going to call it FREC. And then we're going to put in 52, 57, 62, 67, and so on. I forget what all the numbers are here, just a second. 52, 57, 62, 67, 72, and 77. So We have 72 and 77. And then we're going to put our frequency in here. So there's 2, there's 1, there is, let's see, 7, 18, and 11. 7, 18, 11, and then 1 again. And we're going to go into our menu. We're going to ask it to do statistics, stat calculations, and one variable stats. We're going to tell it there's one list and that X list is data. But we're just going to change this and say that our frequency list is frequency. And we're going to hit OK. And it's going to tell you my standard deviation is 5.238. And if you go back here, that's what we got here. Our mean, if you look at the mean, it's going to tell you it's 66.75. And our calculation, if we scroll up here, it's 66.75. So that's how you use the calculator. I would encourage you to use the calculator, but that is what standard deviation is.